My name is Yuan, and a lot of my colleagues just call me Fan, just for the easy part. And I'm from Oxide. Today, we're going to talk about a little bit about how database auditing and anomaly intrusion detection can help for the SQL injection case. There was already a topic last year, I think, in Black Hat about web application attacks, detection, and kind of a wide coverage. But in this topic, I'm going to talk about academic research with my master project about how database auditing and anomaly intrusion detection will help for the detection case. I'm going to skip some of the slides since it's common knowledge for you, and we'll have some interesting thing later on. Web application security, everyone knows it's very important, and think about it. When you have a web application, how many times you don't have a database in your backend? Let's take a look at some real penetration test example. I have to blur some of the screenshot here. So we have a info.jsp. If you pass an ID and you return a information page back. But if you pass an ID and 11 less than select count star from all users, you still get the same page back. What does that mean? First, this is vulnerable to SQL injection attack. Second, this was Oracle, right, in backend. So, because it has system tables there. Third, in the system user table, there are more than 11 users. So if I go ahead and use 12 instead of 11, I got error 500 internal server error. What's that mean? In the system user table, there is exactly 12 users. Since this end condition doesn't match anymore, this 500 error page comes back to me. Now I can go ahead and figure out there's one username whose length is 4. Now the job becomes a little easier, right, for the attacker, because you just need to gain what kind of combination of the characters were in for this username. But do you need to guess from A to Z or 0 to 9 one by one? You don't have to, right? Because you can just cut in the middle and become very efficient for your injection. So it took me like less than 5 minutes to gain the real username in this case. And what we can do next, you can figure out what are the table names, what are the table column names, right? There are all kinds of dictionary hold this information. But I'm going to stop here since you got the idea. I'm not going to reread this definition again because I think everyone has its own definition of SQL injection, and they all mean same thing. But I think everyone is busy in doing the SQL injection attack, but few people will think about try to categorize them or try to, from another angle, think about for the detection. So I took a brief, try to categorize this SQL injection attack from thousands of the different kinds of attack. So if you think of any other big categories, just let me know. Look this as a first version. So first category, privilege escalation, right? Accessing system tables, calling stored procedures, like command CMD shell, right? You will drop the tables from a web application user. All those things are not supposed to do, right? Privilege escalation. Second, return rows the pattern malformed. So look at this example. Select username from user. This is a very common example, right? username equals something, or 1 equals to 1, and the password equals something, 1 or 1 equals to 1. How many rows do you think this will get returned? It will return all the rows that is inside the user table, right? Username table. Third category, union selections, a big category, right? First one, privilege escalation, a big one too. So this union one is very, very difficult to detect. But we will talk about the 3 categories one by one when we're down the road. Before we talk about the work and ideas, let's take a look at the existing mechanism. Input validation, right? Very important, and I think there was already a topic about this. Web application, IDS, firewall, right? Homegrown methods, making use of regular expressions. Regular expression is a good thing, give you kind of a fuzzy way, but also with the pattern recognition ability. But I'm not going to go deep for this one. The limitations of signature-based idea solutions, probably everyone kind of has an idea. The limitation including both false positive and false negative. Why? Because if you want to chasing, I want to chase the SQL injection by some fuzzy characters, right? Or by the parameter value getting very long. In that way, of course you will get a lot of false positives. But if you say, okay, I'm going to gain all the patterns that is going to be for the SQL injections, I tried very hard to get all the signatures. It's very, very easy to have all kinds of different evasion techniques to work around the ideas. SQL injection attack is a little bit different with the traditional one, like a buffer overflow. With one attack released, we can write at least tens, if it's not hundreds, of different kind of evasions, right? So these are going to lead all the false negatives if you want to go this way. But one thing we should never forget about web application is the database. Because after all, what is SQL injection targeted to, right? This is the database. So our suggestion is that we should always doing the detection in 2 layers, database layer and the web server layer. And in web server layer, we should doing besides the signature, we should doing the anomaly detection. So we will talk about that down the road. What is database auditing? Database auditing is all about who is doing what, on which object, and when, right? 4W. So, but the interesting thing is that it can audit really something we will suffer from SQL injection attack, like privilege escalation, unexpected actions, and malformed patterns. So we suggest we should start as a process for the web application. Grant just enough privilege for the web application, the database account, to access the database. Sometimes we also need to grant, revoke, and grant again. Why is that? How many times we mixed the concept of schema owner and the application data owner? Think about when you deploy a web application. After all the coding is done, QA is done, then you create database account for the web application to access, right? So this database account will first create all the tables and maybe views or store procedures. But then after the web application is running fine, do you think it still need to be the same privilege? Do you think it still need to be able to create a job table? Because this was the original one, created a table, then it will have the ability to job the table, right? So all the web application database, this data application owner need to do after it's running really is querying some data table, updating, inserting, right? Calling some its own stored procedures. So after privilege side, we can define the triggers for the more granularity and audit. I'm going to use Oracle as an example, even though just now the CISA doesn't seem to be like Oracle. So, but the idea will be general. For example, you can audit job any table by the web account by access. You can audit not exists, auditing all the SQL statements which fail because the target object does not exist. You can audit the alt, delete, update on certain specific tables. You can audit select any table whenever not successful. You can always fine-grain the auditing using the triggers and even some fine-grain auditing of the database provider itself to the column level. For Microsoft SQL Server, I had also little comments since just now I think we had some fun about comparing the MS SQL Server and the database and the Oracle. From auditing point of view, the architecture itself, Microsoft SQL Service one was a little bit worse. So, but I didn't get paid by Oracle or Microsoft either way. So after that, we talk about web application layer anomaly intrusion detection. So we used a neural network-based anomaly intrusion detection, which based the algorithm self-organization map. So by its naming, the good thing about this algorithm is it will try to categorize different events to map n dimension to 2 dimension, and furthermore, with each categories keep its own space, so that different kind of events will keep their distance from each other. So before the neural network training and detection, we have to do the modeling part. This is the hard one. There are a lot of challenges, like how to score and digitalize the items, how to lower the number of false alarms, but not to miss the real attack, right? For example, you want to be gain slowly, but increase linearly when it's calculating the anomaly score. There are 5 attributes we get from the web application layer: parameter value length, parameter abnormal score, status code, in traffic and out traffic. Notice that every item is a number. So in the training phase, we have the web log parsing, normalization, scoring. Notice that each CGI URL will have its own patterns because different URL has different patterns, right? You cannot just mix them, otherwise you need a lot of false alarm. How is the parameter abnormal score get generated is kind of a key for this part. And also notice that we have to use fuzzy but half awareness approach for the detection. For example, everyone knows that HTTP 500, just now you see, right? It's a strong indication for SQL injection. But HTTP 200 or 2XX is normal one, right? So there's a natural space in between, and when you gain the events, this space can always contribute to the neural network detection. Here's a sample web log you can see by a SQL injection case. Again, there are 2 things you notice in the web application layer, right? It becomes abnormal. One is the parameter the value of the parameter get kind of longer. Second, there are special characters, like abnormal characters inside, right? So after the training, there will be an XML get generated to store all the patterns for each URL. This will use in the detection case. So how do you detect? SQL injection usually contains several steps, right? When you try, finally I succeed, right? So when you gain the abnormal score statefully, you kind of gain more confidence. But if you want to correlate the database layer and the web application layer, timestamp is still the key. But you can do more things like the object name and action name. These kind of things will be appeared in both of the layers. So if you audit both normal and abnormal events in your database and let it run a certain period of time, if you try to visualize this by the database user and its object is trying to accessing, this is just an example to give you that how abnormal will work in our database layer case. So you see the patterns get kind of repeated right here, but then you see some infrequently event which is actually evil here. This just to give you an idea. Of course, you can make use of the actions against the objects, these things. So after we get the self-organization map data, I used the MATLAB to do the visualization. As you can see, due to the nature of this algorithm, the normal events and the attack events will be naturally appear in different neural network space. And again, when you feed in the attack events again, it will still sitting the right front this space. So this gives you the confidence of distinguish each other. Further research work including post data. This kind of we are doing on right now. More abnormal pattern detection on the audit side. Remember I mentioned the third category, union selection, right? When you select something, union select something else. This is very, very difficult in the IDS layer to detect. It will drive you to mad because this is just the normal thing, right? But if you look at the database audit side, you will see one user in the same timestamp is doing two actions on two objects and with the same session ID. This is very, very important information for you to catch this kind of attack. But the idea is the union selection could be normal, right? Even in your normal application case. So in your training case, you need to catch the pattern, and the detection case, you need to distinguish these patterns. And of course, we need a more realistic, much bigger, wider environment. So there are some commercial products, like Oxide, I think everyone knows, has been leader for a while, has all kinds of agents, aggregation, correlation, visualization, reports, data mining, Net Continuum, Web IDS, Firewall, Lumigent, database auditing, and many more. So here are some references I have been using for the search work, and I want to say thank you to my professor, Black Hat, everyone here, and all my friends. Thank you. Any questions? Or everybody tired? Maybe. Thursday afternoon. You can, you have my email. You can always shoot me an email. I would love